Welcome to your own channel of Right Funda. Here is another interesting problem from rotational mechanics, rolling motion problem. Let's read the question. A cylinder of radius r rolls inside a parabolic surface defined by the relation y is equal to kx square as shown in the figure. Find the critical value of k that permits the cylinder to roll continuously inside the parabola. So this is my parabolic surface is there, this one, and on this parabolic surface, taking this at the origin, at the bottommost point, at this the origin we take, then the equation is equal to y is equal to kx square, and a cylinder is rolling on this continuously. It is rolling continuously rolling. So what is continuously rolling? So this function can be anything. Y can be equal to 2k square, y can be 3k square, y can be 4k square, y can be 2.5k square, y can be root 2k square. Any value is possible. So question is asking for what critical value of k this pure rolling on this curved surface continuously is possible. Continuously possible. Now you have understood the question. Now you may pause the video to try solving the problem. After that, again, you can resume the video and you can see the solution. I'll be discussing the solution right now. Now, let's make the strategy of solving the problem. How will we be solving the problem? See what happened, it is going and is saying the rolling. When it roll, what will happen is static friction force act on this body. Static friction force act on this, and there is static friction force does not dissipate any energy. So as energy does not dissipate, then only it can do in a simple harmonic motion, or it will continuous rolling motion will be performing. Periodic motion it will be performing. Okay? Rolling motion is performing in like this. It is going like this. Static friction force will be acting at this point, and smoothly it will move like this. Only force that will be under the influence of which it will be moving, the mg sin theta will be there, one value, or gravity component will be there, and there is a friction force and will be moving, and normal friction will be there. Okay, so it will keep on moving. Only the conservative force which will be doing work is the gravitational force component, that will be the conservative force, and that will be working by this is equal to because of that there will be work done will be there, and work energy will be, mechanical energy of the system will be conserved. Then only it is possible. Okay, so let's see what will happen. Suppose different k value will take, and what will happen, taking the origin at the taking the bottommost point at the origin of the coordinate system. Suppose I draw a parabola like this. If I draw a parabola like this, and if this is my cylinder, then cylinder will be rolling like this, continuously rolls, and it will be rolling like this. No problem with there. We have solved this type of problem also. Suppose this k value I can decrease or I can increase. Suppose this is a value here. Okay. So this is a value there. What will happen? And gradually it will be coming, and it will at this point rolls and will go. If I still decrease this value, if I still decrease this value, then what happens? It will become like this. 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 This is also parabola. So at this position, let's see, check if it can it roll or not. If it comes like this, no problem. It will be going like this, no problem. Now see, and it comes, it suddenly hit the other wall. As it comes here, it suddenly hit the other wall. As it hits the other wall, and not touching the bottommost point. As not coming to the bottommost point, it is hitting this one, and suddenly an impulsive force will come into picture. And because it's an impact, some energy will be lost. Some energy will be lost, and it may be bounce up also. It may be loss of energy will be there. It may not go up to that distance also, and the rolling condition may get disturbed also. Rolling condition may get disturbed also, because at both the places friction force and normal friction will start acting. So this we get the strategy how to solve this problem. So what should happen is that for the proper rolling to take place, it should not be further rolling this. Further there is still more problem will be there. You see, it will be coming. You can check here. It will be coming by this side. Come like this from here, and suddenly it will hit this point, and it will be bounce up from this point when you go. So what should happen for our case, that this value, the curvature should be such that at this point I have taken the origin. Origin is at the bottommost point. So this is my origin. This is my coordinate system origin. So at this point, what happens? The radius of curvature of this path, should not be more than radius of curvature must be greater than the radius of the cylinder. Radius of curvature must be greater than this one. This will be a greater radius of curvature as compared to this will be there. If this has the steepness will be there and the radius of curvature is small than this, then the problem will be there. So radius of curvature of the curved track should be like this. So those who could not get the earlier clue, now you got the clue. Now again you can try solving the problem. After that, once you decided this one, after that nothing there is a simple mathematical process will be there, and we will be able to solve this problem. This radius of this cylinder is given as the r, and this is my radius of curvature of this. And in the mathematics, we know that any function is given to you, y as a function of x is given to us, any y as a function of x is given to that, we can find the radius of curvature at any point. And the formula for radius of curvature is given by this one. This is the formula for radius of curvature. Okay, this is my formula for radius of curvature. Radius of curvature says that is equal to 1 plus dy by dx the whole square to the power 3 by 2 by d square y by dx square is equal to radius of curvature at any point. Right? The coordinate geometry, we know this one. Any point, this is the formula for radius of curvature. So when you go to first, this is the first differentiation of y, a whole square, 1 plus this whole to the 3 by 2 by second differentiation of y with respect to x. So what the formula is given to us to see, we'll check the formula, then it says that y is equal to kx square. So from this we can differentiate this first, dy by dx, I can find the 2kx, I can obtain this, I can substitute the values here, and there is another quantity we got, we can differentiate it again and we can find the d square y by dx square can be obtained. So d square y by dx square will be equal to 2k. So two quantity we obtain, this two quantity we can substitute and I can get the value of my radius of curvature at any point on the curved track. So if I see this one and I will substitute in my equation, radius of curvature equation, our radius of curvature is 1 plus, in place of dy by dx, I put 2kx, and in place of d square y by dx square equal to 2k, I substitute this value and I got the this one. So I want to find out at the bottommost point. So 0, 0 I will substitute. So if I did 0, 0 I will substitute, this quantity becomes 0. Okay. So this is equal to 1 by 2k, and according to our strategy, according to our concept that we build up, that we got that condition for no impact with the track is that radius of curvature at the bottommost point should be greater than equal to radius of the cylinder. So if I take the value of radius of curvature at 0, 0, 1 by 2k we got, I will substitute this value, then we can easily obtain the conditions. Then 1 by 2k should be greater than equal to r, or 2k should be less than 1 by r, or k should be less than 1 by 2r. This is the condition in the equation y is equal to kx square. That was my equations were there. In this equation, the k value should be less than 1 by 2r, or max to max 1 by 2r should be there. This should be the condition. For example, you take radius is equal to, suppose your 2 meter. Suppose our radius is equal to or 2 meter, then this k should be less than 1 by 4. This can be anything less than 1 by 4, 0.2, 1 by 4 may 0.25, so 1 by 25 or 1 by 0.24 or 1 by 5, 1 by 6, any value that is possible. For more than 1 by 4 will be there, then it is pure rolling, continuously not possible. If radius equal to 3, then this should be equal to less than, k should be less than 1 by 6, should be less than equal to 6. That's the thing there. The question was saying that for what value of k, the body will be, cylinder will be continuously rolling on the surface, and we got the condition.